Hey, it's Joel, the 3D printing nerd, and I wanted to look back on some of the more practical and useful prints I've made. This is prompted by my buddy Angus over at Muse, making a video talking about his top three 3D prints that he's made that are useful or practical, I guess is the right way to put it. So let's do this. Are you ready? Go. Welcome back. Like I said, Angus over at Maker's Muse produced his top 3 useful 3D prints, and I thought, well, that'd be a great idea for me to do as well. I don't just print Pikachus, I do some useful printing, so let's talk about the useful and practical things that I've done. Let's do a top 5. I know I said top 5, and I'm gonna give you 6 because I wanted to mention this one. It's almost like an honorable mention. I 3D printed the case for my cell phone. This is an iPhone 6 Plus. It's a large phone, and I figured I 3D print things, I should be able to 3D print the case for it. This is printed using the models from Zetoff.com, and I think I did a video on this not too long ago. But I printed this one in the Raise 3D blue PLA that came with the Raise 3D machine. I did originally have a case printed in ColorFab PLA PHA, but after one too many drops, it did snap. I did have a design in this one, and it did snap at points where it connected that were kind of thin. So I don't know if the ColorFab PLA PHA actually failed, or if it was just because the connection points were too tiny. That's, well, maybe I'll investigate that in 2017. But regardless, I didn't think that the Raise 3D was the end-all be-all. I did try this. This is an orange PETG, and it didn't work as well. It had contraction issues, and so it didn't fit the phone. I'm sure I could print at 101% scale, and it would mostly fit. But the back was also a little bit icky. I printed this on the 3D Gents 1. With the ceramic bed, I had to use a load of magic goo because the ceramic bed for me doesn't hold anything, and it left an undesirable texture on the back, so we get rid of that one. I also tried a nylon. This is some old Tallman nylon that I tried printing with. And I think because it's hygroscopic, I think that's the right word, I think it absorbed too much water. I think there was a lot of popping. I probably could have dried this, but it's flexible. I mean, it's super strong. Look at that. It's just cracking where the layers are super thin, but it would make a good case. I may explore making more phone cases in 2017, but for now, the Tallman, because it was old and filled with water, was bad. I did try a flexible filament, but because the iPhone 6 is so big, it doesn't grip around the side and it just falls off, so that's no good. Finally, I also tried the Protopasta Coffee PLA, just because. Why not? Why not? And the sad part is right here it chipped. I think that's a problem with the model and not necessarily with the PLA. The Zetoff model is weird. It has a lot of errors in it that Simplify 3D has to correct, but it's the only model that's really good that has the case I want for the iPhone 6 Plus. So, but again, this chipped, so we throw that away too. So the Raise 3D did a good job, and it did it with its own PLA. I did print it one more time in the Raise 3D PLA, and it turned out exquisite. So the Raise 3D PLA on the Raise 3D N2 Plus printer seemed to produce the case that worked for me. It's very useful. It protects the back of my phone and the sides for when I'm silly and I drop it on accident. But I like it, and so I want to give this an honorable mention. First up is the shift knob I did for my Subaru WRX, and to this day, I'm still using it. I printed this in a blue ColorFab PLA PHA material, and I did produce a video where I showed you installing it in my car, and like I said, to this day, I'm still using that shift knob. I really liked the feel of the printed material. I know, like Bill over at Punish Props, he says, not finishing a 3D print is like seeing the construction lines, or something like that. But I like that feel, and so I didn't finish it, but over time, just from use, my hand did wear down the plastic a little bit. It's not smooth, but it's not stair stepper. It's kind of cool, and like I said, to this day, I use it and it works really well. Let's talk about this next thing that I printed that was very useful. My daughter wanted a storage box for her Pokemon card. She was very specific in that she wanted, if this was the box here, she wanted her cards laying flat. She wanted them up like this. She wanted a little bit of space so she could look through them and find the card that she needed. And so I went to Fusion 3D. In Fusion 3D, I drew a sketch of what the bottom should be, and then I extruded that up. I also drew a sketch of what the top should be, and I extruded that up. And then I had both pieces, and I showed how you can move them up and down and how the box will work. It's great. So then I know I needed to print it, so I printed it out, and sure enough, it came out great. Here's the box, and here's her card. So she can look through, she can see the cards that she wants to use. There's a little bit of room there for extras, and to put the box on, it just goes like that. Of course, it's all in sketches, so I can change the length of this box. I could change the lid to not be so far down, but my daughter really likes this box. So I'm going to consider that a successful practical use of 3D printing. It really wouldn't be right if I didn't talk about the Fallout nuke plant pot that Angus designed that I then printed. And it's still to this day being used. In fact, that plant is healthy and growing, and every once in a while people on social media do remind me to water the plant, which I do. In fact, just before I filmed this video, I gave the plant some water. It's growing great. That pot is still working to this day, and I love it. In fact, I might print some more for some plants outside this spring. We'll see what happens. A while ago, I did show how you could use OpenSCAD to design brackets for a whiteboard or a corkboard, and then I showed you how to put the holes in them so that you could hang it on a wall, and this way you weren't damaging the whiteboard or the corkboard, and the brackets themselves were holding it in place. And my wife loved the brackets I made for her whiteboard, and she's still using it to this day. In fact, it's being held on the wall, and it hasn't moved from where we originally put it, and it's been very useful to put information on, and the whiteboard is still not damaged, and it makes it easy for her to slide the whiteboard out to write on, and then she can hang it back up, easy peasy. And finally, in probably the most practical use of 3D printing I've done to this date, I had to fix my refrigerator. We have bifold doors, and the door on the left has a flipper thing that flips out when it's closed, and the other door closes against it, and that keeps the air in the refrigerator. This is the little bracket that goes up top that the little flipper thing goes into, and then goes like this, and then it works. It just works. But the problem was this broke. So this sits in the refrigerator like this. And if that little flipper is out and that door is slammed shut, it kills it. It just knocks this little plastic piece out. And that's what happened. I knew this was a chance for me to try to model this piece. And that's just what I did. Click. In order to model the piece, I did have to bring it into Fusion 360. And I first came up with this sketch right here. Let me back that back just a bit. There we go. Here's the sketch. This is the main body. This is the holes for the screws, and then this was the section that I thought could go upward. If I bring this forward a little bit, you'll see I pulled this up a bit more than this section with the thinking I could put an angle right here. That's what I did. Not too shabby. I then pulled or extruded these circles here, and that's where the screws were going to go. So the idea was the threads would go through this hole and the screw heads would sit atop here, and this matched the piece I pulled from the refrigerator. I then added this sketch, and this is my approximation of what was going to be the angle and the piece part for the door to slide into. The piece that I pulled from the refrigerator, of course, was mangled and missing parts of it, so I approximated what was there. Once I was satisfied, I pushed the middle section down, which gave me that indent. Here's the problem. I forgot to zero out my calipers, and so my height was off a little bit. So I extruded that a little bit taller. I then deleted this section because I knew a better way to do it. I brought this out. I then filleted that, and that is beautiful. Satisfied with that, I rounded that corner, I rounded those corners, and I rounded these corners in here. This looks good. I like this. Let's print it. Now that the model is done and printed, I can kind of tell you about what happened there. This was that test that I did where I didn't set the 0 on my calipers correctly and everything was a little too thin, so that didn't work out too well. This was the piece that I printed and it had that piece on it right there. That was where I had to extrude this a little bit taller after I fixed the issue with my calipers. I tested it, it worked, so I wanted to print a final copy. And that's where this one came in. This was the final copy, and this has that side that I extruded correctly and filleted. Everything had rounded corners, but there's something wrong with it. Look at that. So I replicated this piece using Fusion 360, and I was able to come up with the piece that was missing using CAD, but I was just replicating a piece that was easy to fail. So I knew that using 3D printing, it wasn't just going to be a practical use of replicating a piece. I had to make it better. And that's where flexible filaments come into play. As you can see with flexible filament, even though the flap isn't closed all the way, the piece that sticks down is flexible. So when the door is closed and impacts it, it doesn't break it, it just flexes it. And that's very important because every once in a while that flap isn't all the way closed, and every once in a while a child is slamming the refrigerator door. So not only was I able to replicate a piece of the refrigerator in 3D, I was able to print it in a better material than what was originally used and make it better. That's where it gets really good, and that's where 3D printing is going to make humanity better in the future. I think so anyway. That's it. There we go. That's my top 5 practical 3D prints with an honorable mention for my cell phone case. Do you have some practical printing that you did that was really awesome? I would love to hear about it, of course. Leave a comment down below. Hey, if this was awesome, give it a thumbs up. Don't forget to visit Angus's video to see what he chose for his top 3 practical and useful 3D prints. A big, huge thanks to my patrons who support me at patreon.com. Their financial support is integral to the growth of this channel, and I cannot thank them enough. Well, there we go. Hey, you know what? Don't forget to hug each other more often. I love you guys. As always, high five.